Hello, everybody, and welcome to today's presentation, Kubernetes, Impact of DevOps, Development and Deployment in an Orchestrated World, brought to you by Scalyr. Now, I would like to introduce you to our presenter, Stephen Czerwinski. Stephen is the co-founder and chief technology officer at Scalyr, where he focuses on architecture and major technology initiatives. Prior to Scalyr, he spent 8 years at Google, where he specialized in building distributed database systems for consumer applications. He was the back-end technical lead for Picasso web albums and the technical lead for Stratus, where he drove unification initiatives. Prior to Google, Stephen was in the PhD program at UC Berkeley, where he specialized in distributed and mobile systems.
Great. Thanks for that introduction, Billy. And thanks to everyone for attending today. We really hope that this presentation is informative and you get a lot out of it. One thing I'd just like to draw a little attention to in terms of my background, I think it's something like 14 of the last 15 years of my professional career I've spent on a pager rotation in one way or the other. While I was at Google, I was responsible for helping run the services that we were building in production. That meant everything from creating best practices for what was considered DevOps to training new team members on how to handle pages and everything else related to that. And in fact, while I was there, I used extensively technologies like Global Work Queue and Borg, which were the predecessors for Kubernetes. So this topic of DevOps and Kubernetes is really near and dear to me because it's something that I've been living myself for the past decade and a half. Okay, we'd like to start by going over, as a little bit of a reminder, or if you haven't been introduced to Kubernetes before, some of its major features. Now, there is a lot to Kubernetes, much more than we can capture in one single slide or even in a 1-hour presentation. So what I want to do is focus on a few particular features that are relevant to this discussion, and some of these I'll be referring back to when we talk about later topics. First, one of the most important features of Kubernetes is this idea of automated scheduling. This is the idea that you have some sort of notion of a logical goal you have in mind. Like, I want to run 5 instances of this application, each with 1 CPU core and 100 megs of RAM. Kubernetes is the system that takes that logical goal you have and matches that to physical reality. It figures out what physical nodes your application should run on, such that all that works out. Also related to this, Kubernetes has some very powerful self-healing capabilities. This is the notion that if a node in Kubernetes goes down, then any of the pods that were running on that node automatically get rescheduled on other machines that are still healthy and still serving traffic. We'll talk a little more about this next one in a later topic, but this idea of Kubernetes providing very powerful primitives for automated rollouts and rollback. Essentially, what this allows you to do is push updates to your application with 0 downtime. And we'll go into more details on that later on. Another important feature of Kubernetes is its horizontal scaling features. You can very easily go from running 5 instances of your application to running 100, right? And Kubernetes has built-in primitives for load balancing. So you can load balance all your incoming user traffic across all those instances. So you get really great horizontal scaling. Kubernetes also has a very powerful and rich metadata feature set. And what this allows you to do is you can associate descriptive metadata to your applications in Kubernetes that help describe how everything in your ecosystem fits together. So you can have like a label that says, this application is part of my production environment, or this application is part of my staging environment. And all that allows you to very easily understand kind of how everything fits together, and for your team members to really kind of understand what's going on. Infrastructure as code. This is the idea that your production system is captured in a set of configuration files, or Kubernetes refers to these as manifest files. So these configuration files basically represent how your system is being run in production. And the great thing is that these are files that are very easy to understand. You can add comments to them so that, again, you can allow your team members to very easily understand how things fit together. And even more importantly, they can be put into a code versioning system. So you can check them into Git. And so you can use that in order to check and kind of watch changes to your production environment over time. Services, this is another important concept related to load balancing. It is a primitive that allows you to do a lot of interesting test strategies in terms of rolling out new versions of code. You can use it to implement things like canary systems, blue-green deployments, and everything else. Kubernetes also has a very rich role-based access control system. It's very fine-grained. It allows you to very easily control who has access to what. And so you can really take how you want your infrastructure to be used and map that to a set of policies that Kubernetes then enforces. And lastly, and I think this is one of the things that draws people most to Kubernetes, is this idea of resources, not machines. So you don't think anymore about your production system in terms of being, 51 physical machines. You think about your cluster having 2 terabytes of RAM, 1,000 CPU cores. And when you talk about scheduling applications on that, you talk about it at that logical level. I want to use 2 of those cores to run this application. And how that maps to physical reality under covers, you don't have to worry about it as much. Okay, here's a little bit of a block architecture diagram for Kubernetes. Now, there's a lot here, and I just want to draw your eye to a couple key parts of the diagram. First, the Kubernetes master. This is the piece of the system that handles that mapping of logical reality to physical reality. It is what knows about all the applications that you want to be running. It knows how many replicas of each of those that you want, and it decides what physical nodes those applications are going to be running on. It is also what exposes information about that system to all the other components in Kubernetes. This little block in there called the API server, that's what exposes a lot of this metadata to other components in the system. The other
Thanks, Steve. Sorry to interrupt. The screen sharing isn't currently working. Can you try pausing screen sharing and restarting it up again real quick?
Sure.
Yes.
Okay. Okay, great. Sorry about that. Okay, back to Kubernetes, the block diagram. The second portion of the diagram I want to draw your eye to is this, are the Kubernetes nodes, or labeled in the diagram as minions. These are the nodes upon which your physical, that your jobs are actually going to be running. So they're the worker bees in the Kubernetes system. Okay, so the big question for this presentation is, what should you be thinking about, especially in this world of DevOps? And what I want to talk about is, what are the major things that are impacted by Kubernetes? And I think the most important thing I want to talk about is Kubernetes is another system that pushes us further down this road where the operation side of DevOps are now more facilitators rather than gatekeepers, right? So the whole point of Kubernetes is to make it easy for anyone to launch and run applications in your production system. You can let your developers control how they launch it and run the applications that they're responsible for developing. The role of operations now is more facilitators. They're the ones that set up the cluster, that set up the policies, that set up, okay, this team gets this amount of CPU and RAM resources, where this team gets that many. And so, you can take a step back and let the developers run the applications in the system, knowing that they're not going to interfere with one another, and they're going to be allocated the appropriate number of resources and not violate those guidelines. The other thing that I think is great about Kubernetes in terms of DevOps is it codifies a lot of very strong DevOps practices that most people that were new to DevOps would not know about or would not know to follow. And part of this codification is it actually implements a lot of very powerful primitives that you can leverage to make sure that you're running your application in the best manner possible. And I want to dive in a bit on these best practices. And there's a lot of them, so we're just going to focus on a few. But some to consider. I've talked about this before, but I really do want to go into this a little more detail. This idea of infrastructure as code, right? No longer is the state of your production system just something that's kind of kept in some sort of ephemeral state that you have to go and look at, your AWS console to understand what machines are running and how they're running and everything else like that, right? This very powerful idea that the state of your production system is captured in a set of configuration files, it really changes how you think about DevOps. And I should say, Kubernetes by no means is the first system that kind of pushes or uses this model. But I think in our experience, it's the first system that a lot of folks are being exposed to that uses it. And if you're new to DevOps, it might be the first time that you're seeing it in the wild. And really, what this provides an opportunity for is people to easily understand how your production system fits together, how everything works together. They should be able to go in and read these manifest files and understand how the system is composed, so that you don't have to sit there and spend the first month of your life on DevOps getting all the tribal knowledge of how things actually are running in production. And again, this idea of using Git, some sort of code versioning system in conjunction with this, it gives you a lot of interesting things that you can do with it. You can do code reviews to see when the amount of RAM for a application is being increased, or the number of replicas for that application is being increased. You can do code reviews to do policy enforcement. You make sure that people do pull requests to get permissions to make changes to production. And then, of course, there's all the Git automation that you can leverage. Maybe you want to, put in a Git hook that publishes some sort of interesting thing to a Slack channel when you make a change to an application. So there's just a lot there that you can leverage. The update practices. I mentioned that Kubernetes has a very powerful system and primitives for doing rolling updates. And with that, there's a lot of interesting things you can do. I think my favorite among these is the idea of a rolling restart. So the idea here is that your application is composed of, say, 100 instances, right? You have a new version of your application you want to push out. Well, rather than just pushing that version out to all the instances at once, what you can do is say, I want to update 5 of my instances at a time, so that new code is just being pushed out to a few servers at a time. It means that user requests are still flowing to the other 95 instances, so you're only taking a portion of your application processing power out of the pool at a given time. And in conjunction with this, you can do something powerful like specifying a health check. What a health check is it's a way to let Kubernetes know that your application is ready to handle user traffic. So your application is starting up, it has to get to a certain point before it can start receiving user traffic. The health check will allow Kubernetes to know when the application has reached that point. So as you're doing a rolling update, not only are you gating on how many instances are down at any given time, but you also know that when you do consider that instance to be up, it is actually able to receive user traffic, so that you get a good gating effect with that. Similar to updates, you also have this ability to use services to do other testing strategies, such as canaries or blue-green. Services are basically a way to allow you to describe how you want to load balance incoming user traffic across a set of Kubernetes jobs, deployments or daemon sets or anything like that. And what you can do is you can specify something like, my front end service is composed of one deployment that represents my stable production application. But it also is composed of a smaller job that is, another production job that is a newer version of that application code, my canary. And I can have my service load balance across the two of those different applications. So I can see, okay, this new code I'm about to push out, is it throwing any more errors or is it experiencing higher latency? The last practice I like to just draw your eye to here is this idea of policy enforcer. Kubernetes, as we mentioned, has a very rich role-based access control system. You are able to specify very fine-grained policies. For example, you can say anything in the front-end namespace, front-end team members can launch jobs or affect jobs running in that namespace. You can also put further permissions that say, anyone on the ops team can get access to any of the logs of the jobs. It takes a little bit of time. It takes a little bit of effort. Kubernetes is a very powerful system, but sometimes you have to do a fair bit of mechanical work to kind of make things happen. But what it does put you in a position is that you can really create very rich policies that reflect how you want the developers, the DevOps folks to use the system. Okay. How stable is Kubernetes? By this, we don't mean is Kubernetes buggy, is it defect free? What we really want to talk about is how stable is it in terms of feature set and APIs. And it's something worth talking about because when it comes down to it, Kubernetes is under active, robust development. Every 3 months, they release a new minor version of Kubernetes. And there are a lot of changes from between these different versions. Now, the good news is that the architects of Kubernetes recognized that this was going to be an evolving project over time. And so they built in very good primitives from the get-go that allowed this active development to happen without breaking what people were relying on. For example, one of the key primitives is this notion of a versioned API. As a client of Kubernetes, when you connect to something like the API server, you're able to specify what version of that API you want to use. So your client was built against, version 1.9 or something like that. So when it connects to the API server, it says, I want to use, this version. Even if the instance that you're connecting to has newer code, and with that API changes that introduce new fields or new object types, you won't be exposed to that. It will give you the backward compatibility for the older version of the API. Now, obviously, over time, those features will be deprecated and be rolled out. But what this does is it gives you more kind of room for error, more time when you can rely on an older API before a new version supplants that. The other thing that that you should take away from this is you should think about how you're going to roll out updates to Kubernetes itself, right? There are going to be changes to Kubernetes. There are going to be features that you're going to want to capitalize on. There are going to be security fixes. So at some point, you're going to want to update the version of Kubernetes that's running on your production systems. And because of that, you'll want to design your environment accordingly. For example, maybe what you want to do is have a separate development cluster, development Kubernetes clusters. This is where all your developers, launch play jobs and test things and so on. But what it allows you to do is it's a place where you can roll out a new version of Kubernetes first to get some bake time. Or similarly, maybe that's your staging environment. You have a way of, everything that's kind of baking before it goes out to production. You roll out a new version of Kubernetes there first. There is a lot that goes into how you want to deploy your application in Kubernetes. as I mentioned, Kubernetes has a lot of best practices that you can follow in order to make sure that how you deploy your application is done in the best manner possible. You know, from the get-go, of course, one of the first things you want to do is you want to define a manifest file for your application. This describes how many instances that you want to run, how much CPU and RAM you should use. It also is what references what particular Docker image your application should be running. And with that, I'll make just a minor note. You know, when you write your manifest file, it's best practice to refer to a specific image of your container. Don't use like a floating label like latest or something like that. That can lead to bad things. So write your manifest file, reference a particular version of your Docker image, make sane requirements for the CPU and RAM that you want to use. And then you want to do other value-add things. You want to add in Docker labels. You want to say, you know, is this part of my staging environment, my production environment? Is this part of, you know, my this availability zone or that availability zone? What team does it belong to? You know, as you create your manifest file, add in comments. Make sure that it's kind of descriptive and someone walking into this file can understand what's going on. And then you probably want to do additional, more advanced things, such as define a health check for your service. Have a way for the service to say, okay, I am ready to run user requests. And then reference that health check when you define a rolling update policy for your application. All that's defined in the manifest file. Everything that kind of impacts how that manifest how that application should be run is going to be represented in that manifest file. Application configuration in Kubernetes is fairly rich. You know, one of the problems I always had with Docker was how to handle minor configurations that you want to do on the container that you're running. For example, suppose you want to define what database instance this instance of my application should be connecting to. Or maybe you have a API key for some sort of third-party service you're connecting to, like maybe your mail provider or some other third-party service. Obviously, you don't want to bake in the database name, these third-party API keys, directly into your container's image, right? But you need a way to get that into the system so that the right things can be done. Kubernetes provides a feature called config maps that is meant to solve that problem. You can kind of think of it as being able to layer some extra information on the container's file system. Config maps are key value pairs. You can also actually put in whole files into a config map. And what you're able to do in your manifest file is reference what config map or config maps are used by that application. So you can define a config map that defines the API key for your send mail account, right? And you can map into the container where that is stored in the file system, or actually you can even put it into an environment variable. So when your container comes up, it knows to look in that environment variable or look at on the file system for those parameters. And the nice thing about config maps is it's a real Kubernetes object. By that I mean it is stored persistently in the Kubernetes master. You don't have to recreate it every time you bring up a new instance of your application. It's also something that you can create a manifest file for. So you can take your configuration, create a manifest file that captures that configuration, and check it into Git, and then manage changes to your configuration files over time. It's very powerful. The other thing that I'll mention in terms of configuration is annotations. Annotations are another metadata that you can associate with applications. It's similar to labels, but often they're used to provide a little bit more kind of descriptive information about the service, and a lot of times folks use it in order to represent some configuration information as well. For example, at Scalyr, for our Kubernetes support, one of the things that we allow our customers to do is create an annotation on their pods that specifies which the name of the parser that should be used to parse that pod's logs. And so that makes it a really kind of nice feature in that the parser, the information about the parser, is co-located with the pod itself. Our agent, when it goes to pull the pod's log, can also query for the annotations on that pod. It gets that well-known annotation storing the parser name, and we send that up to Scalyr. So it is a very nice way that allows you to put this configuration information into your system in a very descriptive manner. Okay, you can debate how much high availability features you should implement in your infrastructure versus your application. But with Kubernetes, it really does solve a lot of the high availability problems for you. And I should note, Kubernetes itself is meant to be and can be run in a highly available fashion. You can bring up Kubernetes in a way such that you have multiple Kubernetes masters. So if a master fails, of course, the other ones take over. All the state that Kubernetes manages can be spread and replicated across nodes, so that if there is a failure, your Kubernetes system doesn't disappear, and that the masters will continue to schedule jobs and provide information about whatever metadata is stored in Kubernetes. So, Kubernetes has all these great features set up to make sure that it itself is highly available, and also the application it's monitoring can be made to be highly available. So, for example, we've been talking about health checks, right? Health checks can be used for more than just making sure that your application has successfully started. It can be used to report when the application itself is not healthy, and maybe when it shouldn't be receiving user traffic anymore, right? And so if you leverage that, if you use health checks in that way, you can write the individual instance of your application doesn't necessarily have to be highly available, because in aggregate, because Kubernetes is spreading your user requests over all of your available instances, you're able to get high availability in aggregation. So for us, we would certainly make the case that because Kubernetes is already doing all this hard work for you, you will want to leverage that and not have to redo that work in your own application, and just leverage the functionality that it provides. Okay, multiple Kubernetes clusters. Again, this is a topic that you can debate a little bit. One of the core concepts of Kubernetes that I mentioned at the start is this idea that the Kubernetes cluster is managing a generic amount of resources, 5 terabytes of RAM, 1,000 CPU cores, right? To get the best utility of your nodes, you of course want to have as few as clusters as possible. You want to have one big pool of resources, or several big pools of resources that any job can be run across. If you have like a Kubernetes cluster per team, then you're going to be losing a lot of utility you could be getting, because there's just going to be slop. Not every team is going to fully use all the nodes allocated to it. So in terms of resource utilization point of view, you definitely want to have as few clusters as possible. Now, on the other hand, of course, you will want to have more than one Kubernetes cluster. As we mentioned previously, you'll want to have, you're going to want to have at least some clusters where you can test out new versions of Kubernetes itself. Similarly, there are commands that can impact an entire Kubernetes cluster. For us at Scalyr, we make sure that any procedure that we're going to run on production, we do at least once or twice on a staging environment. when you're doing a new procedure, you want to make sure there's no chance that you could impact your production environment. So it makes sense that we do that against a staging cluster, where no external mistake of a script could actually take down all of production, right? So it at least provides the scoping that you can only have impact on your staging infrastructure versus your production infrastructure. So yes, have a few high-level clusters that represent both, security stability concerns and also the need to roll out different Kubernetes masters. And this is also a place where I'll mention namespaces. If you read up on the documentation of Kubernetes namespaces, one of the things that they say in there is it is a way to create virtual clusters. And what they're really kind of encouraging you to use this feature for is creating namespaces per team, right? Virtually, you want to have a cluster for each of your teams, right? You want to have a set of resources that it has available to it, 5 terabytes of RAM, 100 CPU cores, or something like that. And one way you can do that is set up policies that allocate those resources per namespace, and then also set up permissions so that between namespaces, teams can't interfere with one another. So, I'll just mention namespaces, something to think about if you're looking for that kind of Kubernetes cluster per team feel. Okay, now some of these questions that we're going to get into are ones that we've drawn from doing a little reading of Stack Overflow and things like that. The first part of the questions were a little more generic, just how do you use Kubernetes in the DevOps world? But we took a look at Stack Overflow and things like that in order to see what were kind of common questions that folks asked about, and we use that as kind of a signal that maybe there's confusion and maybe there's a place for us to provide a little value. So, for example, one question. Can you actually specify access to specific log files? And the answer is yes. Kubernetes does have very fine-grained access policies. So you can set up a policy that says, for this particular deployment, I want these members to be able to read the logs generated by those containers. And that membership can be different than the list of members that can actually control that job, start and update it and that sort of thing. Behind the covers, logs is just another resource that Kubernetes knows about, and you can set policies against that resource independent of policies against the application itself, who can control it. Keeping the data associated with terminated pods, in my mind, it's definitely a best practice that you want to make sure that you keep it for at least a day or a few days. And the reasoning behind this is there's often a lot of useful information in the logs or the other information that Kubernetes stores about that pod pertaining to why it was terminated. This is actually in our own support for Kubernetes. This is something that we really made a big effort for. Our agent makes a point of making sure that it captures the logs from any terminated instances, even if they only came up for a split second, came down between like the polling interval of when we check for logs. And the reason why we did that is because this is a huge source of information. Often when you're having a problem with an application, it goes into a crash loop where the pods are coming up and terminating very quickly. Well, that's exactly the case where you want to grab the logs to see what the heck is causing that crash loop. Now, of course, the downside of keeping the terminated pods is that this is garbage collection, garbage, right? Over time, of course, Kubernetes wants to, delete the information about terminated pods because it needs to reclaim that space. But still, there's a balance. You don't want to do it right away. You want to keep that information around for diagnostic purposes. Okay, anything coming up that will replace Kubernetes or Docker? So it's an interesting topic. I mean, because it plays into both the cloud providers out there and the ecosystem as a whole. I think the quick answer to this is there's a lot of momentum with Kubernetes. There's nothing on the horizon that I see or other folks here at Scalyr see that's going to replace Kubernetes, right? This idea that it is an orchestration tool that you can use to run your applications, that you can use to do very interesting things. That's going to persist. Now, where the cloud providers come into this is they need to differentiate somehow. The Kubernetes is almost in opposition of what they're trying to do. AWS would love to get you locked into their infrastructure. Same with Google Cloud, Azure. Kubernetes makes the cloud providers, to some degree, generic, right? If you can run your job on a Kubernetes cluster that's backed from Google Cloud, you can just as easily run one that's backed by AWS. And you see the cloud providers trying to figure out how to work with the right strategy. Every cloud provider out there now has their own Kubernetes system. Amazon has their Elastic Cloud Kubernetes service, EKS. Google has its equivalent. And in Google, Kubernetes is, of course, rooted in technology created by Google. So the cloud providers are trying to offer Kubernetes as a service, but they're also then trying to provide differentiators as well, more value adds. Now, whether or not those will allow, make it more sticky that you stick with Amazon versus Google, we'll have to see how the market works out.
Flip share back.
Okay. All right, sorry about that. Now on the Docker side, this is actually a very interesting topic to talk about. There is a version, ever since Kubernetes version 1.11, Containerd has become officially part of the Kubernetes ecosystem. And what Containerd is aimed towards is replacing Docker as a component of Kubernetes. Now, there's a lot to Docker. Kubernetes, for the most part, all it's relying on is this idea that I want to run containers, I want to set policies on those containers, that sort of thing. And so what Kubernetes has tried to do is pull out those specific features that they need, just that core, and then implement it in a kind of its own system, which they're calling Containerd, so that they can leverage that. Now, it's still kind of up to you as a user of Kubernetes, or more accurately, as an administrator of Kubernetes, which container service you're using. But over time, you're going to see, I think, Containerd be more popular just because it has fewer requirements and a little more streamlined to the particular Kubernetes use case. What else to worry about or talk about in the system? I want to talk about two things that you should be aware of. These are kind of next level concepts. Once you are using Kubernetes, once it's part of your ecosystem, these are trends that you're probably going to want to capitalize on. The first I'll mention is Helm. As we said, Kubernetes has a very powerful system based on infrastructure as code. You create these manifest files, that are YAML files that describe how your service should be run. The problem is Kubernetes doesn't have a good way of kind of reusing service descriptions, of reusing manifest files from one instance to the other. For example, suppose you have your application. You want to run it on your staging servers, and you also want to run an instance on your production servers. Well, you probably want to name those jobs a little different. Maybe you want to put staging in the name and production in the name of the containers. You definitely want to run different versions of that code for the two different instances. The problem is that there's no way in Kubernetes by itself to pull in some sort of generic description that describes how your application should be run and then override a few key parameters such as what version should be run. This is one of the problems that Helm solves. Helm provides a templating system so that you can use YAML templates to define your services. That allows you to create common building blocks that you can then leverage in order to build kind of an easier to maintain set of files that describe your production. And this is something that is picking up momentum. It is officially a part of the Cloud Native Computing Foundation. It is going to be one of the blessed ways to deploy Kubernetes applications. I would also say that it's especially important if you're leveraging a lot of third-party applications. For us at Scalyr, we publish a YAML file that our customers use in order to run the Scalyr Kubernetes agent on their clusters. It helps us to be able to publish a common definition that then can be used by our customers. And so Kubernetes does, Helm very powerfully supports this idea that you can rely on third-party templates and applications. The other trend I want to just mention in this context are service meshes, and in particular, Istio. What a service mesh is, it's a way of kind of controlling how your microservices are connected to one another. In some ways, you can talk about it as a really smart proxy. That's proxy requests from one to another. One thing that we haven't talked a lot about in this presentation is Kubernetes has some very powerful primitives on service discovery. You can very easily kind of control how microservices are connected to one another, how they found out about one another. Istio and service meshes take that to the next level. It allows you ways to kind of control how microservices are connected together so that you can do very interesting things, such as enforce authentication between the microservices, so that you can also do monitoring of the services. The very important movement right now in DevOps is pushing out more and more distributed tracing. Istio is a component of that because since it knows about all the requests being made between microservices, it has a way of reporting that information so that your observability platforms can make use of that and help kind of paint the picture of what's going on with the requests flowing through your system. Okay, in terms of prepared material, that's all we had to cover. What we'd love to do is open it up for questions from you folks, and we'll do our best to answer them. So, what's our first question?
So the question that's probably the most interesting relates to what you just talked about here. You mentioned Helm and Istio. Are there any other pieces of the landscape that you think should be interested to gain knowledge?
I think, well, we have a little bit of, kind of our own take on things here, or our own priorities. Definitely anything that relates to how you monitor and run Kubernetes, I think is very interesting to be aware of. And one of the teams that we're working with is actually the Open Census team over at Google. What they're trying to do is provide libraries and toolkits that allow you to put in better observability into your cloud native applications that you're building. So they have features that allow you to very easily publish metrics. They have facilities for doing distributed tracing. And this is one of these great things, is that as more of the development community is converging on these different platforms, there's more opportunities for great libraries out there to provide kind of these very powerful features. And so you can, very easily put in metrics and just retracing into your application and export that, and then use your favorite observability platform, i.e. Scalyr, and kind of understand what's going on with your application. And I think it's a very powerful thing. I know the folks at Google are very invested in doing this because they want to see a great ecosystem out there that supports developers building very powerful microservices in as easy a way as possible, and in a way that they can understand what's going on with very little effort.
And then one more that makes sense for us is, how do you deploy stateful apps like Redis?
Yeah, this is a tough one. We, to a certain degree, we didn't touch on the idea of stateful apps too much in this presentation because it's a big rabbit hole. Kubernetes definitely from the get-go kind of focused on the stateless apps because it's just easier. So they wanted to tackle that from the beginning. And I think the plan all along was then to better support stateful apps down the road. There are primitives in Kubernetes that allow you to address some of these things. For example, you have this idea of node constraints. You can identify a node in your system that has some particular quality. For example, maybe it is, I have the Redis database, or I have the replica A of the Redis database. And then when you define your Kubernetes manifest file, you can specify that that application requires a particular node constraint. It requires to be run on the node that has the replica A of the Redis database, and similarly like that. And there's other primitives similar to that where you can very easily control kind of like where state is stored, how your applications, how your pods map up to that. There's also, I forget in what version of Kubernetes it was introduced, but there's also a concept now of a stateful set, and you can use that as a primitive as well to capture some of these notions.
Cool. That seems to be the basic